Hello and welcome to section 12.6 on long division for polynomials. If you're using the ebook, this is in the intermediate algebra text in section 4.5. So first, let's look at some things related to long division for whole numbers. So as an example here, we have 687 divided by 5. So if we're going to use long division to carry this out, okay, we're going to say, okay, 5 goes into 6 once, and then you do 1 times 5 is 5, and subtract, so that's a difference of 1, and then we carry the 8, and then you play the game again. 5 into 18 is 3, goes in 3 times, 3 times 5 is 15, subtract, we get 3, and then carry down the 7. 5 goes into 37 7 times, 7 times 5 is 35, and subtract, we get 2. Okay, so we stop right here, and this 2 is what we call the remainder, and we can write the result of this division as follows. We have this 137, and then we have this remainder portion, which we can write as just 2/5. Okay, so we're saying that 5 goes into 687, 137 whole times with a remainder of 2. And we call this expression a mixed number. Okay. Now, though it's not common to write mixed numbers in the following way, I can write this as 137 plus 2/5, right? When you say 137 and 2/5, that and is really indicating an addition. And it's this format that we're actually going to use when working with polynomials. Okay, now a little bit more terminology. This 137 we call the quotient. As we already said, the 2 is the remainder, and the 5, the thing that's doing the dividing, we call this the divisor. And then the 687, the thing being divided, is what we call the dividend. Okay, so we have the following format here for a division problem. Dividend over divisor is equal to quotient plus remainder over divisor. Okay, so now with this in mind, let's go ahead and look at some examples involving polynomials. Okay, so here we have, for our first example, x squared plus 5x plus 6 divided by x plus 2, and we're going to divide here using long division. So we'll set this up in just the same way we did the division problem with whole numbers. So my divisor is x plus 2, and it's going into the dividend of x squared plus 5x plus 6. And you start out in just really the same kind of way you do with whole numbers. Okay, we're going to think, how many times does x go into x squared? Or put another way, what can I multiply x by to get x squared in return? And that would just be x. And I'm going to put the x directly above the x term of my dividend. Okay, so now what is this x going to do? Well, it's going to multiply this divisor, x plus 2. And so it's actually going to distribute to each of these terms, the x and the 2. So I'm going to get an x times an x, which will be x squared. And then I'm going to get x times 2, which is plus 2x. And then what am I going to do? I'm going to subtract. Okay, now one way we could do this is to say, I'm going to subtract this entire quantity and just put this in parentheses there. And then you just have to remember, well, this negative is really distributing to each of these terms. So just keep that sign straight when you're doing your subtraction. That's perfectly fine, but I think that can lead to some sign errors. So what I would recommend, as opposed to doing this with parentheses, I would do the following. First get rid of this, and then I'm going to say, so when we subtract, doing a long division problem like this, my recommendation would be to change the signs of each term and then add. Right? Subtraction is really adding the opposite. So if I change the signs of each of these terms, so make the x squared a negative and make the positive 2x a negative 2x and then add, I really am subtracting there, okay? And the nice thing about doing it this way is it's going to lead to fewer sign errors. Okay, so x squared plus a negative x squared, well, those cancel out as they should. And then I have a 5x plus a negative 2x, and that would be a 3x. All right, and then we're going to go ahead and carry down the 6 and then just play the game again, right? So let's go ahead now and say, well, how many times does x go into 3x? So now I'm thinking x into 3x. Well, what times x is 3x? That would be 3. And now this 3 is going to multiply the divisor, so it's going to multiply the x to give us a 3x, and it's going to multiply the 2 to give us a 6, and then I'm going to go ahead and subtract, and to do that, let's go ahead and change signs and add. And notice when we do that, everything will cancel out, and I'm left with a 0 remainder. Okay, so now to write down our final answer here, our quotient is x plus 3. And then I could write plus 0, the remainder, divided by the divisor x plus 2. But since the remainder is 0 there, I'm just going to leave this as x plus 3. So we would be done there. Okay. Now, I do want to say one thing before we look at the second question here. This really is the kind of problem we would have looked at back in section 12.2 when we talked about simplifying rational expressions. So we can also do this particular problem we can also use factoring. So what would that look like? Well, if I factor that numerator, I'm going to get the quantity x plus 2 times x plus 3. And see now the factor of x plus 2 drops out, divides out to 1, and that's going to leave us with this x plus 3. And I think this factoring approach actually is a lot simpler than this long division approach. Okay, but unfortunately, the factoring approach won't always be available to us. Okay, this divisor may not go into the numerator evenly like it does in this example, and the numerator may not even be factorable at all. Okay, so while it does work here, let's look at question 2 now to see, okay, an illustration of where, although I can't factor this numerator, I can still perform the division using long division. So this problem starts out in pretty much the same way because I still have x squared and 5x. It's just the 10 that's different. So x goes into x squared x times, and I'll put the x over the x term of the dividend, and then I got x times x is x squared, plus x times 2 is 2x. And then we go ahead and subtract by just changing sign and adding. And so the x squareds will drop out, and I get 5x plus a negative 2x, and that's a 3x. Carry the 10. Now x into 3x, that'd be 3. And distribute, so now 3 times x is 3x, plus 3 times 2 is 6. And then go ahead and subtract. And here, we're now going to be left with a remainder of 4. Okay, so here I'm going to write the answer as follows. I have my quotient here of x plus 3, and then I have my remainder of 4, and then I have my divisor of x plus 2. So I'm doing quotient plus remainder over divisor. And that is the result of this division. Okay, great. And so now let's go ahead and look at one more problem here. Number 3. And this one, we have x cubed, so degree 3 polynomial. So x cubed minus 3x squared plus 7x minus 4. And it's being divided by x minus 5. So our divisor is x minus 5. So I'll go ahead and set this up just so I have the others. And then that's dividing into this degree 3 polynomial, x cubed minus 3x squared plus 7x minus 4. Okay, so now we're going to start off by asking how many times does x go into x cubed? Or in other words, what times x is x cubed? Well, that would be x squared, and I'm going to put the x squared over the x squared term of my dividend. Okay, you can see that these powers of x cubed, x squared, x, and the constant, these really play the role of place value when we're doing long division, much like the ones, the tens, the hundreds, thousands place value turn out with whole numbers, right? So here, now I'll go ahead and distribute the x squared. X squared times x is x cubed, and then I'll have a x squared times minus 5, so minus 5x squared. And then go ahead and just change signs and add. So the x cubes drop out, and then I'm going to be left with a positive 2x squared. And then we'll carry down the plus 7x. And then just play the game again. X into 2x squared, well, that'd be plus 2x. 2x times x is 2x squared. 2x times minus 5 is minus 10x. Go ahead and subtract by changing signs and adding. And that's going to give us a 17x. And then finally carry this negative 4 down. X goes into 17x 17 times, and now distribute 17 times x is our 17x, and 17 times minus 5 is a minus 85. So then go ahead and subtract, and 17x's drop out, and I'm left with an 81. Okay, so now to write our answer, we have for our quotient x squared plus 2x plus 17, and then I do plus the remainder of 81 divided by the divisor of x minus 5. All right, great. The last thing I'm going to say in this video is that look at this example. Our degree here of the dividend, this is a degree 3 polynomial, and we're dividing it by a degree 1. What's the degree of the quotient? That is degree 2, right? Because of the square. So I have a degree 3 divided by a degree 1 winds up being a degree 2. Okay, look at these examples here. We had a degree 2 divided by a degree 1, that came out to be degree 1. And likewise here, degree 2 divided by degree 1, that's a degree 1 quotient, okay? So more generally, what we're seeing here is this pattern that if you have a degree here of, say, 7, and this is degree 2, okay, the degree of your quotient is going to be the difference in these degrees. So if I do degree 3 minus degree 1, in other words, I'm going to get that degree 2. So in the next video, we will go ahead and pick up with more of all of this, really, and I'll see you there. All right.